Okay, now in the second video, you're not going to see a plus or a minus in sight, so that means you can go back to your properties of exponents, and you don't have a radical. Radicals are going to come into the problem, but you don't have a radical right away. So I have a base of x, okay, and I then take the 2/3 times a negative 3. Okay, so you have to use a calculator to do so. 2/3 times negative 3 is going to be -2. Okay, so that's what you have. Now, if you have a negative power, you need to rewrite the problem right there. Bring that x downstairs, and now it's rewritten as +2, and a 1 goes on top. Okay, and I can forget that. So, do I have a fraction on the bottom? No, I don't. Okay, so I don't have to worry about having fractions on the bottom, so I can just bring over what I have. There'd be no radicals, and that's already simplified, 1 over x squared. Okay, on the next problem, so my bases are 5 and x. So 5 is to the power of 1, but it would just be to the first power. And on x, I take 2/3 times -1, and that's going to be -2/3. Okay, now with that negative power, you need to rewrite the problem and bring that x to the bottom so we can rewrite the -2/3 as a +2/3. And now you got a fraction on the bottom. Okay, you have a fraction of 2/3. And remember, you can't have fractions on the bottom. Okay, no fractions on the bottom. Well, it's just a variable x, okay, so I bring in another factor of x, I put a third, but 2 plus what would give you 3? It'd be 1, okay? So 2/3 plus 1/3 would be 3/3, which is just 1, okay? And now that goes away. But then you got to remember to bring the x to the 1/3 power on top, okay? When you bring it to the bottom, you got to bring it on top. So I now have x to the first, and 5 to the first, and then here I'm going to eliminate the bottom from there, okay, because remember the fractions now I want to make into radicals, so it'll be a radical 3, and inside the radical 3 we put x to the first power. So 5 to the first is 5, x to the first is x, then I make a radical 3 over x. That's the answer, okay. Okay, next problem. There's one key point later on we got to get to about fractions on the bottom, okay? So first I take 2/3 times -12 for the x and the y. That's going to be -8. Now on the y we take -1/6 times -12. 2. Okay, since I see a negative power, we have to rewrite it and move that negative to the bottom where it becomes x to the 8. And the y to the second stays on top. Okay, you have any fraction powers on bottom? Nope, you don't. So you're good to go over here now. Okay, so y to the second, the whole powers just carry over. And I don't need any radicals because there were no fractions. So I have y to the second, x to the 8. Okay, next problem. This time we have a base x on top and a base y on bottom. So I distribute out, take both those times 15, so we're going to take -2/3 times 15. It's -10. And as far as y go, we take -1/3 times 15, and that's -5. Okay, now since I see negative powers, we make a bar right here, and we got to flip those. Okay, the y and the x have to switch places, and then both their exponents can be written as positives. So that's gone. Now, you got any fractions in the denominator? Nope. You just have a 10, so we don't need to bring anything new in. We don't have to rationalize. Okay. So I have y to the 5th, take the whole powers over, and I don't have any fraction powers, so that's y to the 5th, x to the 10th. So far you're thinking this is pretty easy. And so far it is, okay? Now the only base I have is y, so I have two exponents. Since it's multiplication, we add them. 1/2 plus 3/10. Four-fifths, okay? Now we have a fraction, but it's not on the bottom. It's positive. I don't need to rewrite it, okay? It's positive, no negative exponent, and the fraction's on top, so I can now go over here. Well, the only power I have is a fraction, so I get rid of the fraction by making a 5th radical, and then y to the 4th. And you really can't simplify that, and that is the answer. Okay, now the only base you have is x, okay? And this time, since it's a division, you're going to minus the exponents. 3/5 minus 3/10, okay? I got 3/10, okay? Okay, now two questions. We got any negative exponents? Nope. And the fraction you have a fraction, but it's on top, so that's okay. Okay, so now do I have any whole exponents? Nope, I don't, so I go for the fraction. So I make a 10th root, and that 10th root I put x to the 3rd. Then my 10th root carries over, and it's just x third, because you don't have any number you could possibly simplify. Okay, now this one here is okay. So we got bases x and y. Since they're both on top, I'll write them on top to start with. And again, we're dividing, so it's 2/3 minus 1/2, okay? So I take 2/3 minus 1/2, okay? And I got 1/6, so it's x to the power of 1/6. Now as far as the y go, again it's subtraction. We got negative 1/4 minus negative 1/2, okay? So I take negative 1/4 minus negative 1/2. And I got 1/4. Okay, do you have any negative exponents? Nope, you don't have to rewrite it. You got fractions, but they're on top, so that's fine. Okay, but the fractions that I have, I don't have any whole exponents that I can just bring to the front, so I have a 6 and a 4th. So first let's take care of the 6. I make a 6th root and I put x to the 1st. Now I need a 4th root with it, and then the 4th root I put y to the 1st. Okay, so no outside factors, so I bring my radicals in. And we have a variable, it's to the 1st, so we can just write x. Variables to the 1st, you can just write y. Okay, right there. Okay, now the last three, there's a new thing I want to clue you in on, a new possibility to get rid of fractions from the bottom, okay? And using this sheet here. So on top I got 16 times x, and on bottom I have 81 times y. So let's talk about 16. It's to the 1, so I take 1 times 1/2. That's just 1/2. Then x, 14 times 1/2 is 7. 81, we're going to take 1 times 1/2. That's 1/2. And then on the y, okay, we're going to take 18 times 1/2. And that's going to be 4. Whoops, yeah, 18 times 1/2 is 9. My bad, not sure why I'm overthinking that. Okay, now do you have any negatives? None of the exponents are negatives, so you don't need to rewrite it. Okay? You have a fraction on the bottom, but when the fraction exponent has a number as its base, before you just write a times 81 and a times 81 to the 1/2 power, okay? Look at your radical sheet, okay? We have a 2. I'm not crossing it, I'm circling it. So I'm going to look at this list and see if 81 is here. It is. 81 is equal to 9. So another way you can get rid of the 2 is if you cross that out, both the 81 and the 2, and put 9 to the first power. Okay, I'll replay that again. So I pay attention to the bottom, and that determines the list I look at, and it's 9, okay? So 81 and its little 2 go away, we have 9 to the first. That's another way to get rid of the fraction on the bottom when possible. Okay, if it's not on the list, it's not possible, and you have to times, and then what fraction would make a whole, and all that stuff. But again, we wanted to keep our eye peeled for that, okay? Okay, so let's see what we got here. I carry my wholes over, okay, x seventh, and then down here we have 9 to the first times x to the ninth, and then I make my radical of a 2, because I can get rid of that, and it's 16 to the first. So x to the 7th, 9 to the first is 9, and then x to the 9th. Now I make my radical, okay, and I don't put a letter because there's no letters in there, okay, so I go simplify the radical. 16 to the first is just 16. And 16's on here, it's 4, so it equals 4. So 4 goes to the front, and the radical, since there's nothing inside it, is eliminated. So that's my answer, 4x to the 7th, 9x to the 9th, okay? Okay, next problem. So we have 8 times x and 27 times y, okay? That's a 1/3 out there. 1 times 1/3 is 1/3. 6 times 1/3 is 2. 27, 1 times 1/3 is 1/3, and 9 times 1/3 is 3, okay? Now, any of your exponents negative? Nope, so I don't have to rewrite the problem. But you have a fraction, okay? So it's on bottom. I'm going to circle it, but since it's a 27, let's see if 27 is on the list of cubed roots before I go make a radical 3 and worry about that. Before I write times 27 to the 2/3 and times 27 to 2/3, maybe there's an easier way, okay? So I look up 27, and oh, it's here. So I can cross out the 27 and 3 and put 3 to the first power. Now that's a quick way to get rid of it. That only works in certain situations like this, so check your sheet. Now if it's not on the sheet, you got to do it the old way. Okay, so all the whole exponents we carry over. 3 to the first, y to the third. The one fraction I have, I make a cubed root out of it. It's going to be 8 to the first inside. So I have x to the second. 3 to the first is 3 times y to the third. Okay, I make my radical. I don't have any letters inside, so I try to simplify the number that's on the inside. 8 to the first is just 8. So cube root of 8 right away equals 2. So again, we transfer 2 to the front, and the radical is eliminated because it's empty. So that's my answer, 2x squared, 3y to the third. Okay, then my last one. You just got a 125. You're going to take 1 times negative 2/3. Negative 2/3. Since we have a negative power, we're going to rewrite it. That goes to the bottom, and that now becomes positive 2/3, and we got to put a 1 on top. So that's gone. I had to rewrite it. Now, do you have a fraction on bottom? You do, okay? But let's see if the cubed root of 125 is here. So I go look at the 3 list, and oh, it's here. It's 5. So I cross that out, and we have 5 to the second now because there's a 2 up there, okay? So the whole number, the 1 carries over, and the whole number here carries over, and I don't have a radical, okay? That's 1 over 25. 1/25, okay? So that's a new way you look at simplifying radicals, okay? And then the last one we're going to go over. We got 8 times x times y, and then 27 times x times y. Or no, don't put that down there, okay? So 1 times 2/3 is 2/3. x, we got two of them. We got 9 times 2/3 on top. That's going to be 6. And then since I'm dividing, I then subtract. And I take 2 times 2/3, which is 1 1/3. When you minus that, it's going to be 4 2/3. Okay, so that's two separate powers, so 4 2/3. Now the y, take 3 times 2/3, and that's going to give you 2. And since we're dividing, we minus. 12 times 2/3 is 8, so that would give me -6. 27, 1 times 2/3 is 2/3. Okay, so I see a negative power, so I need to rewrite it. 8 stays put to its 2/3 power. The x stays put to its 4 2/3 power. And then the y's got to come down here, so it becomes a +6. And then the 27 stays put because it already has a positive power. So leave it where it lies. Okay, so the negative's been dealt with. Now, do you got any fractions? Yep, but they're with a whole number base. Okay, so look at that, see if you can get rid of it the quick way. So look at your cubed roots. 27's in the house. It's there. It's 3. So I now have 3 to the second. Not because now the fraction's been dealt with. Okay, the whole powers. We actually got 3 of them. We got y to the 6 and 3 to the second. Okay, those just carry over. And the x to the 4th. And then look on top. Now you come to your fractions. They both have the same denominator, 3. So I make a cubed root. And in that cubed root, I put 8 to the second and x to the second. Okay. Okay, simplify where possible. So you got x to the 4th, y to the 6th. 3 to the second power is 9. Okay. And then the cubed root, the variable stays put. Then how about 8 to the second? Okay, well, I'm going to make a cubed root, and 8 to the second is 64. Now first, let's look it up. Oh, it's right there on the spot, so it equals 4. So I put it times 4 in the front. Okay, your radical can't be eliminated because you got x second, though. Okay, there we go.